Hello everyone, myself Himakshi Bharali. I am a student of MCA first semester from Dibrugarh University. Today we are going to learn one of the most important topics in C programming, functions. Functions help us to divide a large program into smaller, manageable parts. Before we begin, let's take a quick look at what we are going to learn today. In this session, we will cover the following points. At first, we will understand what a function is and why it is used in C programming. Then we will see types of function in C, types of user-defined functions, functions structure, example, function parameters, function calling methods, and finally we will discuss recursive function in C. So now let's move to the introduction to function. A function is a block of code that performs a specific task. A function can be reused by the programmer in a given program any number of times. In easy way, we can say instead of writing the same code again and again, we can put it inside a function and reuse it whenever needed. So it helps in reusability, readability and debugging of code. Now let's understand the syntax of a function in C. This is how every function is written in your program. Every function in C follows this basic structure. Let's break it down part by part. Return type. The return type tells us what kind of value the function will return. For example, if the function returns an integer, we use int. If it does not return anything, we use void. The function name is the identifier. It's what we use to call the function later in the program. For example, we can name it add, display or calculate just like variable names. The parameter list is written inside parentheses. It contains variables that receive values when the function is called. For example, int a, int b means the function takes two integer inputs. The function body is written inside curly braces. Here we write all the statements that define what the function actually does. Finally, the return statement is used to send a value back to the place where the function was called. If the function does not return anything, then we skip this part. Now let's talk about why we actually use functions in C. What are the advantages? The first and most important advantage is reusability of code. Once you write a function, you can use it again and again in your program or even in other programs without rewriting the same logic. This saves a lot of time and effort. And next, functions make your program easier to debug and test. If there's an error, you don't have to check the whole program. You can just test the specific function where the problem might be. That means finding and fixing errors become faster and simple. Functions also help in reducing code length. Instead of writing the same piece of code multiple times, you just call the function whenever you need it. This makes your program shorter, cleaner, and more efficient. Improves readability and organization. When you divide your program into smaller functions, it becomes much easier to read and understand. Each function performs a specific task, so your code looks more organized and structured. Even someone reading your program for the first time can understand what's happening. And then allows modular programming. Functions make modular programming possible. That means you can split a big program into small, manageable modules. Each module or function handles one part of the task. Later, if you want to update or improve something, you can modify just that function without affecting the rest of the program. And now we discuss about the types of functions in C. There are two types of functions, built-in functions and user-defined functions. In built-in functions, they are already defined in C libraries, and in user-defined functions, they are created by programmers. Now, let's learn about the types of user-defined function in C. These functions are the ones that we create ourselves to perform specific tasks. In C, functions can be categorized into four main types based on whether they take arguments and whether they return a value. Let's discuss each type one by one. No arguments, no return value. In this type, the function does not take any input from the user and it also does not return any output. It just performs its tasks inside the function. For example, void display. This function might just print a message on the screen with arguments, no return value. In this type, the function takes some inputs or arguments, but it does not return any value to the main function. For example, void add int a, int b. It can add two numbers and print the result directly inside the function. And then no arguments with return value. This type of function does not take any arguments, but it returns a value. For example, int get value. This function might take input from the user inside the function and then return that value to the main program, and then with arguments and with return value. This is the most commonly used type. The function takes input through arguments and also returns a result. For example, int a, int add, int a, int b. It takes two numbers and returns their sum to the main function. So these are the four types of user-defined functions in C. Now, let's look at the structure of a function in C. Every function has three main parts: declaration, definition, and function call. Function declaration. This tells the compiler about the function name, return type, and parameter. For example, int add, int comma int. Here add is a function that takes two integers and returns an integer. Next, function definition. This is where we write what the function actually does. For example, int add int a comma int b return a plus b. Here the function adds two numbers and returns the result. Next, function call. Function call used to invoke the function. We use the function in the main program by calling it. For example, sum is equal add 5, 10. When the function add 5, 10 is called, control jumps to the function definition, executes it, and returns the result, which is then printed. Let's take an example to understand the structure of a function in C. Here the add function is declared, defined, and then called inside main to calculate the sum of two numbers. So our next topic is function parameters. In C, there are two types of parameters used in functions. First one is Excel parameters, values passed from the main function. These are the real values or arguments passed to the function when it is called. And the next one is formal parameters, variables that receive values inside the function. These are the variables defined inside the function that receive the values from Excel parameters. So Excel parameters are the values we send and formal parameters are the variables that receive them inside the function. And then the next topic is function calling method. In C, there are two main ways a function can be called based on how values are passed to it. They are called by value and called by reference. At first, call by value. In this method, a copy of the Excel value is passed to the function. Changes made inside the function do not affect the original value. And the next one is call by reference. In this method, the address of the variable is passed to the function. So any change inside the function affects the original variables. So, in short, call by value sends a copy, call by reference sends the address. That's how C allows us to control how data is shared between functions. Now, let's talk about recursion in C. A recursive function is a function that calls itself directly or indirectly until a certain condition is met. It helps in solving complex problems by breaking them into smaller, simpler sub-problems. It helps solve problems like factorial and Fibonacci series in a simple, repetitive way. So we take example to find a factorial of a number. To find a factorial of a number n, factorial of n equal to n into n minus 1 factorial. So the function can call itself again with n minus 1. In this syntax, the base condition is used to stop the recursion, otherwise it will continue forever. The recursive call is where the function calls itself with a change parameter. Its call performs a smaller part of the problem until the base condition is true. So we take an example of factorial of a number. In this example, the factorial function calls itself inside the function body. For each call, the function of n decreases by 1, and when n becomes 0, the function stops calling itself. The result then goes back step by step, giving us the final answer. This process is called recursion, and it's very useful for problems like factorial, Fibonacci series and tree traversal. So recursion means a function calling itself again and again until a base condition is met, making the program simpler and elegant. So to summarize, a function is a reusable block of code. It can take inputs and give outputs. Using functions makes our code organized and easier to maintain. Thank you so much for watching.